calculus and computer science principles, I made a little web app that explains the basics of calculus. So first I'm just going to run through the app and show everything it does, and then I'll get more into the connection. So this is the home screen, and the first section of the app is just what is calculus. So calculus is a branch of math that studies changes in functions. It helps us to understand how objects move and change in real time by looking at specific parts of functions that define them. Calculus is used in many fields such as physics, economics, geography, statistics, chemistry, and many others. Overall, differential calculus is based on instantaneous rates of change as just a very general overview. So the next section is on limits. So the first question underneath this topic is, what is a limit? So the formal definition of a limit is if f of x becomes arbitrarily close to a single real number a as x approaches c from either side, the limit of f of x as x approaches c is a, which can be seen in this graph below, and it kind of helps to look at C and A, and just look at how they relate to each other to understand that. So an easier way to look at this is the limit evaluates the output or y value that the function is approaching on both sides of the input. So the values right before and right after x, and the point doesn't have to exist for the limit to exist, but the limit must be approaching the same number from both sides. So there's a little practice problem here. That is on determining limits graphically. So looking at the graph, what is the limit of f of x as x approaches 2? So maybe you don't completely understand this topic and you think it's 3. So if you get the incorrect answer, wow, you hear a fun little sound, and then you see that you got the question incorrect, and it gives an explanation of how you find the right answer. So this one says that x equals 2, which it kind of tells you what you should be looking at. The graph of f of x is approaching the y value of 0, and it shows you that point and marks on the graph so you know what it's meaning. And then you can go back, and if you understand it better, get the right answer and get a page that tells you got it correct. So then you can go back to that, and the next question under the limits section is, how do you write a limit with correct notation? So in the limit notation below, a represents the x value that you're evaluating the limit of, f of x at, and then f of x is the function you are evaluating the limit of, and c represents the y value that the function is approaching at the x value of a, which can all be seen on this graph. And an important note is that you only continue to use limit notation until you substitute your x value into the function. So you can test yourself on correct limit notation as well. Which of the following is correct limit notation? And you might also not understand this concept well and think that it's B. And then you would get that's incorrect, and you could look at B is incorrect because you don't use limit notation once you've substituted your x value in. So here you can see that the x value is already substituted in, so it wouldn't be in this limit notation. If you chose A, you could see that it's incorrect because there's no argument to the limit, and C is the correct limit notation. So then you can click C and get it right, go back to limit notation, and that's all for the limit section. So the next section is on derivatives. So the first question is just generally, what is a derivative? So they are the slope of a line at a point. The equation above, which is the limit of the difference quotient, shows how one can find the slope of the tangent line as x changes. This concept requires knowledge of limits as it analyzes features of a graph over intervals or around certain values. So limit is the instantaneous rate of change of the graph f of x at a point. And if you're wondering, well, what's the tangent line that it mentions here? The tangent line, you can click on this button to find. You can also, if you go back to this page, you can get to the same page about the tangent line. So there's two different ways to get there. But a tangent line is the line formed as 2 points of a secant line, which is a line that intersects a curve at least 2 points. Get closer and closer together, which you can see in this image right here. The tangent line does not exist if the slope of the tangent line is undefined, so it's a vertical tangent line, or if there's a sharp point at that value on the graph. The tangent line is made up of the slope of the graph at a point, which is the derivative, And to get the tangent line from the derivative, you can use point-slope form. So you can plug in the slope, which is the derivative value, at a point, and then put the coordinate values into the x and y spots to create the tangent line. So if you want to practice a tangent line problem, you can click test yourself, and this is a practice problem on writing the equation of a tangent line. So if f of x is 6x plus 7, or f prime of x is 6x plus 7, what is the tangent line equation at the point on the function -2, 4? So maybe you forget to plug in the x value into the derivative to find the slope, and you get y minus 4 equals 6x plus 7 times x plus 2. So that's incorrect, and this would help you to see how to get the correct answer. So it explains that to find the slope at x equals -2, you need to plug in -2 to that derivative, find f prime of -2, which is 6 times -2 plus 7, which equals -5, and then you use point-slope form at the point -2, 4 to get the equation of tangent line y minus 4 equals -5 times x plus 2. So then you can get it correct and go back to the tangent line. And the final section on derivatives is, what do derivatives tell us? So derivatives can tell us a lot about the motion of an object just from its position equation. We can know the instantaneous velocity, which is the first derivative, speed, which is the absolute value of the first derivative, and the acceleration, which is the second derivative, just from the position equation and its derivatives. So from these different equations, we can get a lot of information, such as when an object will hit the ground, when it's stopped or changing direction, or when it will be at a certain height. So that's the derivative section, and that's about all there is to the whole app. I really enjoyed reviewing some of the basic principles of calculus while also learning some coding basics. This was our first real coding project in the class, and I definitely enjoyed it. Here I can scroll through some of the code and show you what it looks like. It'll load. But there's also 16 total screens in the app, so there were a lot of different parts to it. This definitely gave me a lot of appreciation for websites like Albert.io and Khan Academy that work so well at such a large scale. Even though my app was really simple, it took a lot of work and time to make sure everything was how I wanted it and ran smoothly. I thought it was really fun to try and teach calculus at a basic level in an engaging way that would hopefully help more people to understand than just reading from a textbook. If we end up sharing our apps with our class, I'd really like to see how younger students in my class, like freshmen who aren't in this level of math yet, would be able to understand it and how well they do on the example problems. So that's my connection to calculus from Computer Science Principles. I definitely enjoyed doing it, and hopefully it would be helpful to someone with minimal calculus knowledge.